Welcome to the session of Cauchy's integral formula evaluation. Consider this problem. Using Cauchy's integral formula, evaluate integral over the contour C, z plus 4 by z square plus 2ez plus 5 into dz, where C is the circle, modulus of z plus 1 minus I equal to 2. So here the given contour is modulus of z plus 1 minus I equal to 2, which gives you, by replacing z equal to x plus iy, you will get x plus iy plus 1 minus I equal to 2. This implies, separating the real and imaginary part, you will get x plus 1 plus I times y minus 1 modulus of it equal to 2. Now, by removing this modulus, you can able to get this as a circle with center minus 1 and 1 and radius 2. So, in this circle, we have to analyze which are the singular points lies inside this contour C. For finding the singular points, we are equating the denominator of this function to 0. That gives you, by using quadratic formula, z equal to minus 1 plus 2i and z equal to minus 1 minus 2i. We all know what is z equal to minus 1 plus 2i. It referring the point by replacing x plus iy equal to minus 1 plus 2i. Okay. If you are comparing in this manner, you will get the point z equal to minus 1 plus 2i referring minus 1 comma 2 as the point. So you are having the circle with center minus 1 comma 1 and radius 2. This is the circle. I am plotting the points. This point is minus 1 comma 0. So this point can be minus 1 comma 1. And this point is, since the radius is 2, this point is going to be, here you are going to have minus 1 comma 3. Likewise, this point is minus 1 comma 1. Okay, we have to observe this now, whether the point minus 1 comma 2 and the point minus 1 comma minus 2 lies inside circle or not. Definitely we can able to see that since the radius of the circle, okay, here the center is minus 1 comma 1, minus 1 comma 1. Therefore, since the radius is, okay, radius is 2, here what is the circle radius? 2. So since the radius is 2, definitely we can able to see that minus 1 comma minus 2 lies inside C. Sorry, minus 1 comma plus 2 lies inside C. Here also the radius is 2. Therefore, minus 1 comma 1. This point is minus 1 comma 0. So 1 unit and then 0 to 1. So this point, let us take it as minus 1 comma minus 1. Okay. Therefore, the point minus 1 comma minus 2 definitely lies outside the circle modulus of z plus 1 minus I equal to 2. So here I am assigning the point z equal to minus 1 plus 2i as, for simplicity, alpha, which lies inside C, and z equal to minus 1 minus 2i, which is taken as beta, lies outside C. Therefore, this integral over C, z plus 4 divided by z square plus 2z plus 5 into dz, we can write the denominator as like z minus alpha into z minus beta, where alpha and beta are zeros of this denominator. So here, by making use of Cauchy's integral formula, we are going to evaluate it. Therefore, the point which lies inside the contour only we have to keep it in the denominator. Other functions, other terms, we have to combine it with the numerator. So already numerator z plus 4. This z minus beta in the denominator, I am clubbing it with the numerator. So I can have f of z as z plus 4 divided by z minus beta. Now apply Cauchy's integral formula for this. What is the formula? You will get 2 pi I f of alpha. What is alpha here? Alpha is minus 1 plus 2i. Okay. So here, what is f of z? Z plus 4 divided by z minus beta. In this put z equal to alpha, you will get alpha plus 4 divided by alpha minus beta. Alpha is minus 1 plus 2i plus 4 divided by alpha is minus 1 plus 2i, beta is minus 1 minus 2i. Substitute it and do the simplification. Numerator will become minus 1 plus 4 is 3 plus 2i divided by minus 1 plus 1 gets cancelled. Okay. Then 2i minus of minus 2i will give you 4i. To remove I in the denominator, I am multiplying and divide by I, so that I am getting 3i minus 2 divided by minus 4. By multiplying minus sign in the numerator, you will get 2 minus 3i divided by 4. By substituting this value f of alpha equal to 2 minus 3i by 4 in this place, you will get 2 gets cancelled. In 4 you are having 2 times. So 2 minus 3i divided by 2. This I we have to multiply inside this parenthesis, that gives you 2i minus 3 into I square. I square is minus 1. I square equal to minus 1. So substituting that value, you are having plus 3 divided by 2. Hence, we are having the integration value z plus 4 divided by z square plus 2z plus 5 into dz equal to pi times 2i plus 3 divided by 2. So here, this problem is little bit tricky to find out the circle. Okay, if you are having the contour given in this form, you have to do it in this manner. Hope you all understood. We'll do the next problem. Consider this problem. Evaluate integral over c, z square into e power 1 by z into dz, where c is mod z equal to 1. So the same given problem, we can write it as the contour integral over c, z square divided by e power minus 1 by z into dz. Now we have to find out the singular point. To get the singular point, put z equal to 0. What you will get? E power 1 by 0. Because why we are putting z equal to 0? We are having in the denominator you are having only z. So by putting z equal to 0, z equal to 0 is the singular point. So here, by putting z equal to 0 here, minus 1 by 0 will give you infinity. We know that e power minus infinity is 0. Therefore, the point z equal to 0 is the singular point. Now we have to identify whether the singular point lies inside the contour. We know that the circle mod z equal to 1 is representing the unit circle, okay, with center 0, 0 and radius as 1. So definitely the point, okay, z equal to 0, z equal to 0 is this point, okay, lies inside the contour C, okay, mod z equal to 1. So at this point, we can use the Cauchy's integral formula. What is it? Integral over c, z square divided by e power minus 1 by z into dz equal to 2 pi I into f of 0. Why it is f of 0? The point is, singular point is z equal to 0. So what is f of z here? The numerator term, it is z square. Put z equal to 0 here, you will get 0. Therefore, integral over c z square into e power 1 by z into dz equal to 0 according to Cauchy's integral formula. Now we'll see one more problem based on this concept itself. Evaluate line integral over the quantum c tan z into dz where c is mod z equal to 2. What is the meaning of mod z equal to 2? Mod z equal to 2 means it is a circle with center 0, 0 and radius 2. Now we first find out the singular points. To find out the singular point, tan z you are having, that tan z we can break it like sin z by cos z. Put the denominator to 0. So you are getting z equal to cos inverse of 0. Cos inverse of 0 you will have pi by 2, 3 pi by 2, 5 pi by 2, etc. In these 5 by 2, 3 pi by 2, etc., we have to identify which is the point lying inside C, inside the contour C. So you can observe that the point z equal to pi is nothing but 3.14 divided by 2 in comma 3 times 3.14 divided by 2, etc. You can observe that 3.14 divided by 2 gives you 1.57, and the second point is going to be 3 times of 1.57. So definitely we can say that from the point 3 times 1.57, it is going to lie outside the circle C, okay, and the point 1.57, okay, here the circle is nothing but a circle with center 0, 0 and radius is 2. Radius is 2. So you can observe that z equal to 1.57. 1.57 you can have it here. Okay, 1.57 definitely lies inside the circle mod z equal to 2. So we are going to evaluate this integration value by making use of Cauchy's integral formula. Okay, the other points of z are lies outside the circle. So by Cauchy's integral formula, integral over c f of z by z minus a into dz is what? 2 pi a into f of a. Now integral over c sin z by cos z into dz equal to 2 pi a into what is f of a? The point a is pi by 2. So f of pi by 2. What is f of z here? Sin z. Therefore, 2 pi a into sin pi by 2. Sin pi by 2 we all know the value as 1. So we are getting the answer as just 2 pi a. Hope you all understood this problem. We'll see in the next session. Thank you all.